Hello everyone, hope you're all doing good. So today we are here for grade 5 maths. The chapter today we discuss that is decimals. And here are the list of the lesson today we cover, which is equivalent decimal, wrong decimals, compare decimal numbers, compare the decimal on number line. You can find all the lessons on plusstudent.com. You have to log in by using your email and the passwords that are provided by the administrator. Go to the subject tab, select maths from there, and scroll down. So there are the list of the chapters. Select decimal chapters, and now here the lesson we discussed, that is the equivalent decimal. Okay, this is our lesson, first lesson today. We covered that one. Wait, let me just check my mic and everything. Okay, just give me a second. Is my voice clear? Can you please check everyone and then tell me in the chat? Okay, so just give me a second, everyone. I'm going to checking my mic and everything. Okay. All right, everything is set. So now we start the equivalent today. So first of all, we just check it out. What is basically the meaning of equivalent decimal? First, we check it out that thing. You all know what is the equivalent decimal basically means. Equivalent decimal basically means the two decimal numbers on the two other side. We just check it out. Are these decimal equal? Okay. So for example, if I'm going to take the two decimal places, like for example, that are represent the same values, even if they have different numbers of digits after their decimal points. Okay. Like for example, look at here. These are the two numbers, zero point 0.5. And here I'm going to take 0.50. These are equivalent decimal because why? They both represent the one half. Okay, this zero means nothing, because if there are two zeros here, so these zero means nothing. If there are three zeros, so these three zeros are nothing. The only thing which is important, that is these two things. Okay, these two things are very important in every case. So this is zero point 0.5 and that is here again 0.5. Let's suppose, for example, when you are going to add zeros on the right side, so it means nothing, but when you put the zeros on the left side, so that means some values. Okay, so what are the equivalent decimals? These are the decimal numbers that represent the same value even if they have the different numbers of digits after the decimal points. Okay, look at here, this is the different basically numbers of digits after their decimal points. There are three zeros here, there is nothing zero, but they both represent the one half. So we can say that these are the equivalent. Let's suppose I'm going to take the example of this one. Can you guys tell me 0.7 and 5 here? And here is 0.75 and 0, 0. Can you guys tell me, are these basically equivalent decimal or not? Yes. Are these equivalent decimals? Yes. Why? Because these zeros are on the right side, so that means nothing. Okay. These two places values are same. There is 7 5, this is also 7 5, so we can say that these both are same. So we are basically saying these are equivalent decimal. But if we're going to talk about this one, like for example 0.075, and here it's 75 and again double zero here, so these are not equivalent. Why? Because the zero is in the middle now. Okay, so this represents 0.07, and here it represents the 7. So we can say that these are not equivalent. Okay, here I'm going to write the two kind of decimal, equivalent and non-equivalent. Not equivalent, you guys tell me which one is equivalent. Okay, are these both equivalent or not equivalent? These are equivalent. Okay, now when we're going to talk about this one, 1.1 and 1.01, are these equivalent? If the zero is in the right side, so these should be equivalent, but now the zero is in here, this one and one is same, but here is after point there is zero, so these are not equivalent. Okay, so this is basically the distinguish between the, you can say that, equivalent and non-equivalent decimals. Okay, hope you guys understand this one. Now let's discuss some next question, or let's do the term some test questions. Okay, so now if we're going to talk about some test questions, look at here. For example, if I'm going to write it 0.79 and 0.079, can you guys tell me are these equivalent? This one I'm talking about, 0.79 and 0.079, are these equivalent? No, these are non-equivalent. Okay, so we can say that this is not equivalent. These are not equivalent. Okay, why? Because this 0 and 0 same, but here is the 0 and 7 9 comes until the 7 9 is here, but these are not over the place of 0, so 0 is here, so we can say that these are not equivalent. Okay, now here is the question, 33.80 and 33.8000. Look at here the question, this is 33.80, only one zeros are here, and here are three zeros. Look at here, this 33 is same, this 8 and 8 are same, and the zeros on the right side, there are three zero, there is. So tell me guys, you guys tell me, everyone tell me in the chat, are these equivalent or not equivalent? Yes, everyone tell me, are these equivalent or not equivalent? So these are not equivalent. Okay, so we can say that these are, sorry, these are equivalent. I was just checking this one, because this is 33.8, 33.8, 10 and 30, so these are equivalent. Let's go, and this is the right option. Okay, now for the next question, you guys tell me, is this equivalent or not equivalent? Okay, I'm going to do it this one here. Which decimal is equivalent to 0.6000 here? 0.6, this one, and then here are the triple zero. Now the first option which is given, all zeros. Okay, like first option is all zero. Now the second option that is given, which is two zeros, then 0.60. Second option is this one. Third option is 0.60, and the fourth option is 0.0. Tell me, this is 0.6, so it means that it must be 0.6 here. This is 0.6, no. There is 0.6, no. There is 0.6, yes. But here are three zeros and here is only one zero, but this zero means nothing if there is in the right side, so we can say that if it's 1, if it's 2, 3, or any number, so we mean it means that it's nothing, so this is 0.60 here, so we go with that one, 0.60, and here is our answer, and that is the right answer. Okay, so you understand this one, like how to do it. This is zero point 0.6, we just check it out, this 6 only, not including the 0. If the 0 is in the middle of that, so we are going to check it out. Which decimal is equivalent to 11.610? Okay, now here is 11.610. Let's see the let's check the first one. When we the first one, so look at here, in the first one, 11.6100. In the question there is only one zero, but in the answer there are two zeros, so it means that 11 is same, 6 is same, 1 is same, but there is only the difference of zero. So we already know that if in the zero is in the right side, so that means nothing. So here we go with this option. Okay, and here is the right option. Now hope you guys understand this lesson. So here we discuss the equivalent decimal. Okay, so I'm going to repeat it again. What is basically the equivalent decimal? Equivalent decimal means the number which is equal inside. So only there is a difference of zeros, there is a difference of zero here, but all other numbers are same. Okay, all other numbers are same, only there is a difference of zeros, but that zeros are on the right side, okay, not in the left side, because if the is in the left side, so it means some values, but if the zeros in the right side, so that means nothing. So we can see that for the equivalent, like some kind of this question, this zero is in the right side, there is one zero, and here are the two zeros, so we can say that these two zeros means nothing. But if the zero is in middle of that thing, okay, so we can see that this is a very basically different. Okay, now let's discuss the next lesson. So the next lesson today we covered, which is round decimal. This is equivalent decimal which is done. Now the rounding decimals. Now first of all we discuss what is basically the meaning of rounding decimals. Okay, then here we open it. I don't know why it's not open. There is string. Let's discuss the round decimal. Okay, so there is a rounding of decimal, it means sometime rounding of decimal nearest 10, rounding of decimals nearest, you can say that 100 place. Okay, so first of all we discuss the rounding the nearest 10th placed. Which thing that is important, the important thing to round a decimal number to the nearest 10, you look at the digit in the 100th place. Okay, for the 10th place digit we can see the number is in the 100 place. Like for example, if I'm going to 3.47, okay, this is a basically the number. If it's 5 or greater, so you round 10th digit up. All right, but if it's 4 or less, so you have to 10th digit as it is. All digit after the 10th place are dropped. Understand? Now for example, if you gonna write it down, this one 3.47, so how can we solve it? I'm going, this should be stuck, I think so. So what we do, we can see, we can look the digit in the 100 place, and what we do here, this is the digit that is 7 is in the 100th place. After decimal, this is in, starting from the 10th, then it's 100th. All right, it's not the ones place, tens place, there is ones place, it moves like this way. But when you're going to moving in the basically left side, or you can say that from the this one after the decimal point, so this can be start from the 10th place, this should be 10th, and that is 100th. Okay, So this is the 10th place, this is 100th place. If you are going to round out to the 10th place digit, so you look at the 100th place digit. If this digit is 5 or greater than 5, so you round up. If this digit is 4 or less than 4, so this is the same value and the remaining digits are dropped. 3.47. Now the 7 is greater than 5. So this 4 can be changed into up, that is 3.5. All right, because it's greater than 5. This digit 7 is greater than 5. Okay, if I'm going to write it down here, 7.29. Look at here, this is the 9. We can see this digit always, okay, because this is the 10th place digit and that is the 100th. Sorry. So we can see this digit 9. So 9 is greater than 5, so this 2 can be changed into 3 and this one should be dropped. Let's suppose I'm going to write it down here, 3.43. Can you guys tell me what is the answer of this one? This one is 3. So this is less than 4, less than 5, you can say that. So this should be the same. Okay? And the remaining digit are dropped. All right? Let's suppose if I'm going to write it down here some numbers, 12.29. Now you guys tell me the answer of this one, 12.29. Do it everyone. Solve everyone and then tell me the answer. 12.29. We always check the this 9 if you're going to round out the 10th place digit. So this is 9, so this is greater than 5, so 2 can be changed into 3. The answer is 12.3. Now everyone tell me, is it easy? Okay. This is 1.63. Tell me, there is 3 here. Now 3 is less than 5, so this should be same, 1.6. Okay, this is the way that we round to the nearest 10th place. I'm going to repeat it again. For to round a decimal number to the nearest 10th place, you look at the digit in the 100th place. If it is 5 or greater, so you round the 10th digit up. If it is 4 or less, so you leave the basically 10th digit as it is, and all the digits after the 10th place are dropped. Understand? And here I'm going to write down different examples for that. So nearest 100th place. Now let's discuss the nearest 100th place. Okay. Now we discussed nearest 100th place. We already discussed the nearest 10th place. 10th place is, for example, for the 10th place, that is already discussed. Okay. This should be easy because, for example, there is 5 and 2 here, and there is 3.7 and 7. So this is 2. For the 10th place digit, we check the 2. And 2 is less than 5, so this should be same. And the remaining should be dropped. For this one, 3 point is same. We check the 7. 7 is greater than 5, so this can be changed into 8 and the remaining should be dropped. These are the two examples for the 10th place. Now for the same for the 100th place. Okay, let's discuss for 100th. For 100th place, what we see, we check the 100th place and look at the digit to the right, the 1000 place. If the 1000 digit is 5 or greater, so round the 100 digit up. If it is 4 or less, so keep the 100 digit as it is. Let's suppose, for example, I am going to write it here. This is 3.4681. Let's suppose I'm going to write it this one, 3.4681. How can we solve it? Everyone think about it and then tell me the answer. This is 10th place, 100th place, 1000 place. So we check the digit for the 1000 place, not the 100 place. Now same method, 3.4 is now same. If this digit is greater than 5 or it is 5, so this can be round up. if it is less than 5, so this should be basically as it is. So 8 is greater than 5, so we can say that 6 can be round up, that is 3.47. Let's suppose if this one should be this. So what is the answer for that? So the answer as it is 3.46. Remaining should be dropped. Remaining is dropped because here it's 1. 1 is less than 5, so we can say that less than 4 it means. So we can say that this should be as it is. And here it can be round up. All right. Let's suppose I'm going to write it down here. One more question. You guys tell me the answer. Okay. I was just checking my mic. Okay. So here I'm going to write down 85.85.24. Let's suppose 13. Okay. Now you guys tell me 85 as it is, point as it is, 2 as it is. We round the 4 by checking the 1. This is 1, this is less than 4. So you say that this should be as it is. And the remaining should be dropped. But let's suppose if this one is like this way 85.2471. So this should be 85 as it is, point as it is, 2 as it is. There is 7 now. 7 is greater than 5, so this can be round up and 5. Alright. Hope you guys understand this lesson as well. So now let's discuss the next lesson, which is compare the decimal numbers. Let's discuss compare the decimal number. Now we already discussed the equivalent decimals. Equivalent decimal is so easy. And then after that we discuss the rounding decimals. Now we discuss the compare decimal numbers. Okay, this is a basically rounding decimal to the nearest 10th place. We already discussed rounding decimal to the nearest 100 place. I'm going to repeat it again here for more time. I'm just going to write down the number here 7.365 and 7.361. So for rounding the 10th place, first of all we just check it out the 10th place. So 7 point, this is the 10th place digit, this is 6, that is greater than basically, so we can change it into 7.4. But when we check it out the 100th place, how can we see this is 7.3 as it is, this is 5 or greater than 5, so this can also be changed into 7. Okay, this is 10th place and that is 100th place. But when we see this one for the 10th place, this is also 7.4, and when we check it out for the 100th place, so this can be changed into as it is 7.36, sorry. Okay, because there is one that is less than 5. Is it easy? Now you guys, when you guys practice this one, then this should be easy for you. Which sign make the statement true? Now, now we check it out. So which sign make the statement true? 7.0 or 6.5? We check it out. First of all, write it down the place value chart. Okay. So there is 7.0. This should be start from the ones place, and there is start from the 10th place. 7.0 and then 6.5. Now for the ones place, this is 7 here and that is 6 here. So it means that 7 is greater as compared to the 6. So 7.0 is greater as compared to the 6.5. Okay. Which decimal is greater than the one shows in the diagram? Look at here, how much total value in this diagram? There are total 10 columns. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How much colored? 8 are colored and 2 are not colored. Okay, so the decimal part is 0.8, because when you're going to divide 8 over the 10, so this should be 0.8. All right, so that is your answer, basically 0.8. And then write the 8 tenths as a decimal. 0 is in the basically ones place and 8 is in basically the tenths place. If there are 0.83 is greater than 0.8, so remember 0.8 is equivalent to 0.80. Why? Because look at here, if that is here 0.8 and now here is 0.83, so which 83 is greater as compared to the 0.8? Because this is only ones place, tenth place, ones place, tenth place, and hundredth. Okay, this is also moves to the hundredth one. That's why we are saying that this should be greater as compared to the this one. Let's suppose I'm going to write it here, 7.5 and then 8.1. Here is the place values chart. On this side I'm going to write it down the ones place, and that is 10th place. Okay, so this should be here 7, then it's point 5, then 8.1. Now check it out for first of all the ones. Which one is greater? 7 is greater or 8 is greater? As we can see that 8 is greater. So we are saying that 8.1 is greater as compared to the 7.5. Okay. Now let's discuss this one. There are basically which decimal is less than the one shown in this diagram. Diagram is given, there are total 100 columns and 59 are colored, so 1500 is 0.59. Okay, the decimal shows is 0.59. Now look for the decimal that is less than 0.59. Every decimal which is less than 0.59, if we are going to take 0.4, 0.4 is less than 0.59. How? Remember that 0.4 is equivalent to which one? If you have these two numbers, let me just write it. If you have this number 0.4 and 0.40 and 0.59, like three numbers, which two are equivalent and which one is less than the other one? 0.4 and 0.40, these are equivalent. Why? Because this is the difference of only zeros. We already wrote it. But when we are checking 0.4 and 0.59, okay, when we are checking these two, 0.4 and 0.59, look at how here this is the ones place, 0.4, 0.5, and then 9. This 5 is greater as compared to the 4, so we can say that 0.59 is greater as compared to the 0.4. So 0 is less, and in the question they mentioned which is less. Okay, let's discuss the next. Hope you guys understand this lesson as well. Okay, so we discussed the lesson which is compare decimal numbers. Now compare decimal numbers on the number line. This is a very easy. So we are just going to compare the decimals on the number line. First we discuss that one. What is the number line for decimals? Okay, let me just open the whiteboard. So now for example, for number line we just draw a dot for each decimal place. Okay, like how, for example, if this is a number line, this is the same thing as for the, there is number line for basically For single numbers, we are just going to put it out the plus values in this side and the negative values in this side, and in the middle we are putting zeros. The same thing for that, but if you are just going to draw the positive number line and then we are going to draw the negative number line, this is somehow a difference. Okay, here is 0, which is in the middle. For this side it's only 0. 0.1, 0. 0.2, 0. 0.3, that is only the difference. You are putting the points 0. 0.4, then it's 0. 0.5, 0. 0.6, 0. 0.7, 0. 0.8, 0. 0.9, and in the end it's 1. For this side the same thing with the minus. Okay, all are same thing with the minus, and then here is in the end it's -1. Understand? This is 1 point, minus 1.0, and here is 1.0. This is the number line for positive decimals, and this is the number line for negative decimals. And here is then the middle, this is 0. For simple number line, we are just only putting 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. But when you are going to put for decimal points, so this start from 0. 0.1, 0. 0.2, and then in the end it's 1.0, not 10. Okay, so this is the thing that we have done it. All right, hope you guys understand this one. So we are on, yeah, it's on here. All right, okay. Let's suppose we are just going to write down some numbers on the number line. Okay, let me just write some numbers on the number line. Suppose here is a number line, and we can say that this is 0, positive number line. I'm going to draw only. Let's suppose that is 2, 3, 4, and 5. Let's suppose where is 3.5? Look at here. This is 0. 0.5. Here in the middle is 1.5. Here in the middle is 2.5. Now this is the middle is 3, and then it's 0.5. So here is your 3.5. If I'm going to draw 2.1, so it means that 2 and then here is 0.1. So this is 2.1. Then here is 2.2, 2.3, 2.4, and that is 2.5. Okay, when you are going to check it out like this way, 2 to 2.5, if this is 2 and here is 2.5, so what is in the middle? 2.1, 2, 2.1, 2.2, 2.3, 2.4, and then it's 2.5. Okay, this covered that area from 2, and then it's from 2.5 to 3. Same thing from 3 to 3.5. This is 3.1, 3.2, 3.3, 3.4, 3.5. In this way we are going to cover it like that way. Okay, this is the number line that we are going to discuss. All right, let's, I'm going to draw here a number line. Okay, then you guys tell me. For example, I'm going to drawing it here. This is 0, 1.0, 0.1, 0.2, 0.3, 0.4, and that is 0.5 just only. Now tell me, where is the point of 0.3 on the number line? Here is the point of 0.3. Where is the point of 0.5? There is the point of 0.5. That's it. In this way we are going to draw the points. Okay, now let's do this one. You guys tell me, zero point 0.3 and zero point 0.1. Where are the points of zero point 0.3 and what is the point of zero point 0.1 on the number line? So we know that this first yellow point, this is zero point 0.3 and then is zero point 0.1. And there are some points. We compare these 2 points and check it out which one is closer to 1. They are saying that which one is greater. So you can say that zero point 0.3 is greater as compared to zero point 0.1. Sometimes they are saying that which one is less. Okay, so we first of all we write down these 2 points and then we check it out in the end, like which one is a greater, which is a lesser. Okay, all right, now let's do some test, not test questions, I think so. Just draw it here. Let me just draw. Okay, that is 0 and here is 1.0. This is 0.5. Now where is the point 0 point? Now let's, this is 0.1, 0.2, 0.3, 0.4, and then 0.6, 0.7, 0.8, 0.9, and 1.0. First of all, what is the point of 0.3? So here is the point of 0.3. What is the point of 0.8? This is the point of 0.8. Now tell me which one is closer to 1. This point is closer because look at here, this is the closest difference distance. Okay, and when you're checking these two distance, so that is the bigger, right? So this is the way that we solve it. In this way we are just going to solve it. We just check it out first of all, which one is the greater, which one is lesser, and all that things. All right, now let's discuss some test questions. Graph zero point 0.6 and zero point 0.5 on the number line, and which number is closer to 1.0. First of all, you graph zero point 0.5 and then you graph zero point 0.6. Let's suppose we already draw it here. Let's choose this one. Now check. They are saying that the 2 points. Which are the 2 points? First point is zero point 0.6, other point is zero point 0.5. Sorry, this is zero point 0.6, that is zero point 0.5. And they are saying that which one is closer to 1.0. Look at here. From this point to this point is easy to move, or from this point to this point. Obviously from zero point 0.6 to 10. So we can say that zero point 0.6 is a bit closer as compared to the other. Okay. Hope you guys understand this lesson as well. So today the grade 5 maths. The chapter today we covered is a decimal, and here the list of the lesson, which is equivalent decimal, round decimal, compare decimal number, compare decimals on the number line. So you can find all the lessons on aplusstudent.com. You have to log in by using the email and the passwords that are provided by the administrator. So hope you guys, before starting the next session, you guys make sure to practice all these lessons and all the question. And if you still need any help in any of the question, you can contact tutors. You are using the live chat button that is available on the A plus website. Click that, putting your name, then department, which maths or language you need help with, then just sign. In this way, you directly contact with the tutors. So for now, have a great day, you all. See you in the next session. Bye.